Hi, this is Chuck Wesley James from Cellusys, and today we're going to have a short introduction to the purpose and needs of a diameter signaling controller. Alright, let's take a look at some of the protocols involved. In SS7, we had ISUP and TCAP. Now ISUP did the job of setting up the phone call. It made it ring and set up the circuit switches. Well, that whole job has been moved over to a protocol called SIP, Session Initiation Protocol, and you'll be using that if you're doing voice over LTE. Now, back on the SS7 side, TCAP took care of a little higher level of the control. It actually got you authenticated onto the cell phone network. It determined if you could roam and what services you'd have. Now, and that protocol has been displaced by diameter. So in the LTE 4G network, you're going to have diameter doing that kind of functionality. Now, these are the interfaces that are using the IMS and EPC core network. Some of the critical ones in here will be the S6A interface. Okay, that's going between the MME and the HSS. You'll notice it's called the S6A. That's kind of an unfortunate thing the industry's now done. You need to memorize these names essentially between the interfaces. Now, GY and GX interfaces, they're a little special. They're kind of unusual ones. There's a whole video on those three interfaces coming up later that you can link to after this presentation. If you're roaming, then the S9 interface is pretty important, and the S6D interfaces are pretty important. Okay, so you will have to learn which one of those interfaces are diameter and what they mean and where they go between. Let's face it, this diagram is pretty complicated. There's a lot of connections, and we've even simplified this diagram because really in your network, you're going to have a whole lot of MMEs. So this is why you want to start looking at having a diameter signaling controller in to simplify all these connections. Okay, so let's take a look at the purpose of the DSC. So if you don't have a DSC, you're going to end up with a network like this. It's actually going to be even more complicated than this. It's a mesh network. That means pretty well everything has to get connected to pretty well everything else. And if you were to add a new HSS onto this diagram, you'd have to have every MME connect to that new HSS. So this is an operations nightmare. There's just far too many connections to maintain. Now, it also means you've probably got very little security on here, and you certainly have no one place to go to take a look at where the traffic is flowing and how much, if too much is taking place, or if one node is carrying too much stuff. It also means that you probably can't connect to another carrier for roaming, because you certainly wouldn't want other carriers connecting directly to your HSS and directly to your PCRF. It also means in this you've got terrible troubleshooting going on. You need a central place to do this stuff, which is what a DSC is going to do for you. So if I simplify this, I stick a DSC in the middle. Again, if you come from an SS7 background, that DSC looks a lot like an SS7 STP. The STP takes all the messages, decides where it's going to route them, and sends them out again in a hub and spoke architecture, just like we're showing here. I've simplified it a little bit, but the idea is still there. What this buys you is one central hub for connections. You've got many fewer connections to make. It simplifies your operations, and it gives you a central place to do value-added processing. Okay? By value-added processing, I mean it's one place for other carriers to come into your network and you can secure their traffic. It's one place to do troubleshooting. It's one place to do monitoring. It's also a great place to do a signaling firewall, as we'll see later on. Okay, so let's take a look at what the main DSC functions are and what you're going to hear about as you go discussing them. If you start looking at the standards, you're going to hear about the relay or proxy agent. Well, this is just table stakes, frankly. A message comes into the DSC. It's going to route it to an MME, an HSS, or one of the HSSs to a PCRF, and that's the table stakes. This is what it does, its main raison d'etre. Most of the messages actually have a destination host and a destination realm, so the DSC job is pretty darned easy. The difference between relay and proxy is simply that a proxy is allowed to change the message somewhat. But when you're out shopping for a DSC, that's never going to come up in conversation. They're all going to be able to do proxy functions. Now, a diameter routing agent is actually pretty expensive, so let's take a look at what this does. So on the diagram I've got so far, I'm showing MMEs and HSSs and PCRFs. Well, if you look at the industry standard for a DRA, it's only in front of a PCRF. We tend to get lazy. We talk about DRAs as core routers doing what I'm showing already. But really, it's only in front of PCRFs. So let me change that diagram. A DRA routes messages to specific PCRFs based on something called an IPCAN session. There's another video which goes into more detail about that, but it's a very specific thing, and you probably don't need it depending upon the smarts contained within your PCRF. So if your PCRF is running hot standby or is already sharing the IPCAN session data, you don't need this functionality, and that will save you a ton of money when you go to buy a DSC. Now, there is one important one on this page coming up, the diameter edge agent. So we're going to change back from the PCRFs to the first diagram where we're talking to lots of other nodes, MMEs and HSSs. But the trick here is the diameter edge agent is the entity where other carriers are going to connect. You don't want other carriers to connect their MMEs to your HSS. Operationally, it's a mess. Security-wise, it's a complete mess. So diameter edge agent, the job here is to let the place for the other carriers to come in and do some security. In the SS7 world, we called this a network boundary STP. And it, the network gateway STP, it also did the job of routing your core messages. So there's no reason the diameter DSC can't do both the functions of a DEA and route your core network functions. It's perfectly fine to do that. Okay, so a couple other functions you might hear about. You might hear about the interworking function, typically between SS7 and diameter. Well, you'll hear about it, but frankly, the commercial use cases for this are not great. There's not a lot of them out there, so you probably won't need this in your network. Now, subscriber location function, which is a diameter proxy agent or relay agent, which looks up this great big list of subscribers in your network and then determines where it's going to send it to. Let's say you've got an HSS and you've got so many subscribers you had to divide it to 2 HSSs. Well, where I'm hinting here is this SLF functionality is really only used by the absolute largest carriers. They have to have a huge number of subscribers before it's worthwhile doing this kind of thing. Because if you don't need to maintain this extra list of subscribers on the SLF, then don't do it. There's no reason to provision information more than once. Okay, let's get back to the diameter edge agent because it's pretty important. A diameter edge agent works with a signaling firewall. The DEA's got some security built into it, but it's going to get much more in-depth when you work together with a signaling firewall. In some ways, you can think of the signaling firewall as being a value-added feature on top of a DEA because it connects to it, and that's how it talks to gets the messages. So going to the DEA functions, it takes care of basic message routing. It knows about destination hosts, destination realms, and routes messages. It can do some things like topology hiding, which if you've seen my other videos, I'm not too impressed with as a security feature, but it does those. It'll take care of things like IPsec and DTLS to really secure those nodes and understand who they are. And it deals with that nodal connectivity. That's its job. It's a DSC. The other thing we want the DEA to do is send a subset of traffic to the signaling firewall. So definitely we want it to send any of the traffic that's going to come into your network. We want to send that to the signaling firewall for some extra checks. Maybe the messages that are going between your own MMEs and your own HSS, you don't want to send to the signaling firewall, or you just want to check for throttling to make sure they're not sending too much traffic. So you've got a lot of choices you can make, and the DEA is going to be able to determine which messages will go to the signaling firewall. So the signaling firewall, what's it doing? It is one central place for all the rules. Now remember, we're going to have rules that are going to determine whether or not you're going to send a message back, whether it's fraudulent. Well, if you've got some rules in the signaling firewall and some rules in the DA and some rules over on the HSS and some on the PCRF, when you come to troubleshoot to determine why you have blocked a message, you now have to look in 4 different places. So that's not good. So the signaling firewall should be the central place for all the rules. And it's going to need some pretty exacting reporting and logging of what messages it drops and for what reasons, what rules it hit before it dropped that messages. It's also one central place for all the protocols, because we know diameter is not the only protocol in your network. You're probably also running SS7, maybe SMPP for your SMS messages, and GTP. So you can use the signaling firewall to act for all those protocols at one time using the same database. This will allow you to do per country and per carrier analysis, and much better because you're going to cross those protocols, and it's one central place to look at all the data. Of course, we're going to return, block, or modify these fraudulent messages. The first step in those fraudulent messages is you're going to detect the rules for the GSMA Category 1, 2, and 3 messages that are being specified. So when you get to the Category 3 messages, you kind of need to know some information about the subscriber before you determine what's going on with the message. So if it's your subscriber, the signaling firewall can query the HSS for that subscriber information before it makes a determination on those Category 3 messages. So the signaling firewall is pretty detailed in what it can do, and it's got an awful lot of rules that it's going to bring together and be one central place to do the troubleshooting for that. Okay, I mentioned some other videos. The other diameter videos, first of all, some of those special diameter interfaces, the GX interface, the X6A interface. Well, this video with the link here will describe in more detail what those interfaces are doing and why. The second video is focusing in on diameter security. Now, diameter came a long time after SS7 for the telecom world. Unfortunately, diameter did not improve the security situation. If anything, it left a couple of extra security holes. So I explain what those holes are and how attackers are using them in that second video. You may want to take a look at it. Okay, thank you. That was a short video today. Please keep watching this space. We'll have additional videos, and please keep the comments coming. Thanks.